This is a logo which is point, and we are told that the area of this logo, we are expected to show that the perimeter P of this logo is P equals to 2R plus 18 over U2. Also going to work out the stationary value of P given that R varies, and we're going to check of the stationary point. Now, something that we need to L is given by the formula R theta, where R is the radius and theta is the angle that is given at this point. And then you also need to remember that area is 1 over 2 R squared theta. So this I can to know is now work it out, because we know that arc length is equals to R theta, and in this case it's R alpha because the angle was given. Perimeter is going to be equivalent to what? Perimeter is going to be arc length. We're going to say 2R plus R alpha, 2R plus R, 2R, this radius and this radius plus L, but L is R alpha. You need also to agree with me that we were given the area, and the area was given as 9 centimeters. Then we can be able, because whatever we are, what are terms of, we're going to say area is equals to a half R squared theta, but in this case it's going to be a half R squared alpha because the angle is alpha, and that is going to be equivalent to 9. So meaning that we are going to say now R times 2 both sides, we're going to have R squared alpha is equals to 8. Since we want to find alpha in terms of R, our alpha is going to be 18 over R squared. So this is the expression we're going to use and substitute it at this particular point here. So meaning that our perimeter is going to be, but our alpha is 18 over R squared, so it's going to be R times 18 over R squared. R will cancel with 1 R at this given point, so we end up having 2R plus 18 over R as the expression that we were supposed to show at this point. Let us look at the next question. Given that R can vary, find the stationary value. Because at the stationary point, dP dr is going to be equal to 0. So meaning that we are going to find the derivative of this expression that we have here. Remember, our P is equals to 2R plus 18 over R. So dP dr is going to be differentiating this term. We're going to remain with differentiating this term. We're going to remain with 2 plus differentiating this term is going to be negative 18 over R squared. All right. So because the way you differentiate this, we are going to is equals to 2R plus 18 negative 1. So when you differentiate that, you take the power down negative 1 and then decrease the power by 1. You subtract the 1 there. We are going to have dP over dr is 2 minus, because this 1 comes down here, 18R, negative 1 minus 1 becomes negative 2. But when you now take this power below 18, you're going to have 18 over R squared, but this is a minus. So this is going to be dP dr is going to be 2 minus 18 over r squared. But at stationary point, we know that dp dr is going to be equals to 0. And then we're going to take and equate this to 0. So it will be 2 minus 18 over r squared is equals to 0. And that means it's 2 is equals to 18 over r squared times r squared both sides. So we shall have 2r squared is equals to 18 divided by 2 divided by 2. This and this will cancel out. Then we shall have our r squared is equals to 9. Square root both sides. Our r is going to be equal to 3 centimeters. So at the stationary point, r is equals to 3 centimeters. What does that mean? That means if we are working out the value of the perimeter at the stationary point, value of p at stationary point, value of p at stationary point at r is equals to 3, our p is going to be equals to what? Our p is going to be equals to 2r, because p is 2r plus 18 over r, so it will be 2 times 3 plus 18 over 3, and that's translating to 6 plus 6, and that is 12 centimeters. That's the value of p. Then the next part is finding the nature of the stationary point. The nature of the stationary point can be determined by finding the second order derivative. So we're going to say if dp over dr is equals to minus 18 over r squared, if you differentiate this, it becomes d squared p over dr squared is going to be positive 36 r negative 3, which can be written as 36 over r power 3. That is now the second order derivative. But since our r at the stationary point was 3, we can now find what is d squared p over dr squared at r is equals to 3. At r is equals to 3, this is going to be 36 over 3 power 3, and this is going to be 36 over 27. So which means that our d squared p, d r squared is greater than 0. So which means the nature of this stationary point is minimum point, because the second order is greater than 0. So that is basically what you are supposed to do in order to work out this question. If you are new to Proflan YouTube channel, consider subscribing so that anytime I'm going to upload a tutorial, you'll be notified. See you in the next video. Welcome to another tutorial of Proflan YouTube channel. In this particular video, we're going to have a discussion on how to solve logarithmic equations and the rules that you must know. There's 8 rules that you must know in order to answer any question to do with logarithmic equation. If you're new to Proflan YouTube channel, consider subscribing so that anytime